Good afternoon, everybody. My name is Irma Hermans. I'm a professor in technical art history at the University of Amsterdam, a researcher at the Rijksmuseum, and a visiting professor at the Venice Center for Digital and Public Humanities. The Venice Center very kindly hosts this series of talks, and we are now presenting the third talk in the series. The first two, by the way, can be seen. They have been recorded, so you can look at them at in your own time. I would first of all want to thank Elisa Corot. You see her also on the screen for all the organizing of this series online. And I welcome our third speaker, Professor Holly Rushmeier. And Holly is the John C. Malone Professor of Computer Science at Yale University. She has a long record of very important work in this field, and her current research focuses on material appearance modeling, applications of perception to computer graphics, and applications of computer graphics to cultural heritage preservation. Her past projects include a project to create a digital model of Michelangelo's Florence Pieta and models of Egyptian cultural artifacts in a joint project with IBM and the government of Egypt. She is also co-author of an important text, Digital Modeling of Material Appearance. Today she will talk to us about her research and with recent examples, and we're very pleased to hand over to you, Holly, and hear your presentation. So you need to share your screen.
Yes.
Oh, and people, everybody who's attending, you can put questions already in the chats. And after Holly's talk, there will be also opportunity to ask your questions live. And Zemila Sero will moderate the discussion. So this series, before I forget to mention it, is co-organized with the Venice Center, the Rijksmuseum, NICAS, and CWI in Amsterdam. Okay, Holly, the floor is yours.
Thank you very much. I'm happy to talk to you today about tools for making sense of cultural heritage data. And I'm mainly interested in putting out some ideas we've had that we've tried out, and very anxious to get people's feedback and new ideas for what's lacking, what's needed. So just to give you an outline of my talk, so you have some hint when I'm going to be finishing, I'll give you a little motivation for why I got into this. And we sort of developed two kinds of tools for making sense of data. One that's object-centered, you have a thing you want to understand and do something with. And the other thing is about sites or collections, big areas with lots of things to make sense of. And the motivation is, as Irma mentioned, I've been working on various projects in the past, doing things like 3D scanning of objects, various types of 2D images, building and using databases. So we've all this digital data and stuff. And with that, we build tools to use that stuff. And because I think you're all acutely aware, this is a highly under-resourced area. Cultural heritage in general is so poorly funded compared to anything else you want to think of. So whatever we do, we want to be able to reuse data and tools for many purposes, both to conserve the physical artifacts we have from the past, to assist humanistic scholars in understanding the past, and then to assist people in communicating with other scholars and with the general public, right? Because if we don't have the public benefiting from this understanding, why should they care about funding about conservation and scholarship? So this is, view this as a cycle. We want to contribute to all the elements of this cycle, understanding objects, how they should, what their status is, how they should be repaired or preserved, understanding, why things were made, how things were used, and then trying to present that in appealing ways to the public, with things like storytelling and virtual reality. Irma mentioned my previous projects. I started out on the side of doing a lot of scanning and creating models, more or less focused on documentation, and then a little bit on communication, where these objects would then be used in websites for the public. In more recent years, I've gotten more into projects that involve analysis. For example, in a wholly different non-3D, we had a long project on medieval manuscripts, where it was more about like the physical attributes of the manuscripts, like what kind of inks and their layout. For example, this researcher, Jessica Brantley, is interested in the books of hours. It's not so much about reading the books of hours, because we know what's in them, but it's how they were laid out, what other little things, little songs or pictures and stuff were inserted in such books, and using machine learning to understand the layout and identify little interesting bits in thousands of pages of manuscripts. So in doing lots of projects, we came up with some problems. There were a lot of sort of one-time studies. We'd do things, we'd find things out, and then a lot of what we learned sort of disappeared. There'd be some papers or something about it, and then it was gone. Also, the people we collaborated with always needed a load of technical assistance. Well, here's this program, here's how we use this. Oh, let me do this for you. It didn't let either the art historians or the conservators be independent. They always had to have some computer scientist hanging around with them, explaining to them what we were trying to do. And things just got lost, and things weren't integrated. We'd have this one little project and then it's done. So those are problems that we want to address. And our first effort in this direction was thinking about objects and all the information about an object. And this came up with some sort of informal interactions initially with some of the conservators at the Yale University Art Gallery, and it sort of grew into a larger project. And our first effort was this thing we shouldn't have called Hyper 3D, because that didn't give us a lot of space to go to even more grandiose names. But the problem that the conservator we were talking to had is there's this increasing number of imaging devices. And in the previous talks, you've heard about all the different kinds of imaging that you can do of objects to understand them. And these are just proliferating, right? I mean, we can use the CAT scanners like to get true volumetric data. You can get various surface scans and multispectral and so forth. So you've got this sort of barrage of different kinds of imaging information that we can get. And each comes with its own data type. The surface would be some sort of mesh. There's different imaging devices like this so-called reflectance transmission imaging, where you have an image, but it's kind of an active image where you can move around and change the light source direction and see the object under lighting from different directions. And of course, in previous talks, they've discussed about the full 3D volumetric. So you have lots of instruments, lots of different types of data. So here you have the scholar or the conservator. They have all these imaging sources, and each comes with its own software, with its own displays. And somehow from all of this, you need to make decisions about what kind, what is the state of the object, what kind of treatment is necessary, or in another domain, like how was this made, how was this used. So there's a lot of burden on the user to make use of all this stuff and to learn all these pieces of software. So we're using up lots of unnecessarily computational resources. There's no standardization about, like, if I move my mouse right on this image, what does that mean? Every program has its own rules. And a lot of what we use in heritage is inherited from other areas, CAT scans from medicine, hyperspectral from remote sensing, and their software comes with a lot of stuff built in that's specific to their application that's kind of irrelevant to what we're studying. So for example, even things that are built for cultural heritage, like this RTI viewer from Cultural Heritage Imaging, it lets you look at one of these images from different lighting points of view, but that's all it does. If you want to look at some hyperspectral data, well, now you got to open something else up. Similarly, when you do 3D scans, there's wonderful programs for looking at shapes of objects and doing operations on shapes of objects, but that's all it does, is let you look at the shape. And like I said, there's a lot of tools for hyperspectral data, but a lot of it is for remote sensing. You don't really care about the tree canopy and other things that are sort of built into viewers for that data. And there's, very, of course, expensive software for medicine. And if you can bring in your 3D volumetric data, but it's got built into it lots of stuff about bone and tissue. And if that's what you happen to be looking at in your work, that's helpful. But if you're looking at a panel painting, things that are adjusted to viewing the density of different kinds of tissue and bone really aren't helpful. So we didn't want to reinvent any of these things or the editing and processing that they do. For example, editing meshes that you may capture. And we don't want to sort of build in all their packages because they are constantly changing also. So what we wanted to do is bring in something that would allow a person to view them in a consistent setting. And so this was our model. Instead of having to go through all these different kinds of software packages, have the data eventually come into one unified viewer. And so this is what we came up with. We called it Hyper 3D. And the idea was that you'd be able to do the viewing. And here's a little video of it in action. And the gestures you use mean the same thing regardless of what kind of data you're looking at. So the gestures you use to turn around a 3D volume object are the same as a 3D scanned object. Changing the 2D position of an image is the same as changing the 3D object. And you can do specialized things for special images, like being able to go in and query the hyperspectral data. So this was our first foray into this, and the conservator we worked with was excited about this. But then what? It's sort of like, I have all this stuff, I see it, I come to a conclusion. How do I explain what I saw and what I concluded? I mean, you can take a screenshot of what you were looking at when you had an idea and then write something down, but it really isn't making the most of the experience, and it's not sort of recording how you got to that conclusion. So we went back and took another take on this. And this time we worked in steady collaboration with two postdoctoral researchers that we hired who were conservators. And instead of like talking to somebody and then going off for a month, making some stuff and then bringing it back and saying, well, what do you think of this? We were working together every day and having frequent meetings about what should this tool do. And that was a lesson just in how to collaborate with people who aren't computer scientists. First of all, they pointed out to us, like, think of the mental model of the person using this. There's many kinds of things, not only this imaging stuff, but there's bibliographic references and so forth. And we're looking at each of these things. And each time we look at things, we're forming some hypothesis. And we have all these hypotheses that then we have to integrate in our head and reach a conclusion. And what we'd like in this tool, this new tool, is to bring all of these in so that we can have come to some integrated hypothesis. And also, like, what is all this stuff you're showing us? There's different things going on. We have things, entities, like it may be a particular painting, it may be a particular vase, or it may be a particular person, and there's data associated with that thing, and things sort of exist throughout time. And then we have projects. We're going to a project to plan a treatment, a project to plan an exhibit. Projects have a starting time and an ending time, and you have to make some decisions, and they will involve using some number of these entities in the project. So let's get a mental model of these different components. It's not just a pile of imagery. So the software needs to account for these entities and then projects that use entities. So then we developed ways for the person to, the user to define the entity and then the various image data, text data that's associated with that entity. And then to describe the project and how, what its purpose was and what its goals were. And then understanding, so a project will typically either you create or find the entities that you have and the associated data with them, define your questions, create the project, and then bring in the data and you start modifying it, because analysis isn't just looking at data, but it's enhancing it by adding to it as with your observations. And that is through the major vehicle of annotation. So we redesigned the interface. It may be a bit subtle here, but important things are being able to define entities and projects rather than just keep bringing in image data of one sort and another. And then also, if we're going to have this, we need to be able to navigate all the stuff we've brought in, and we need to be able to search all the annotations. So we have this now, the navigation tab that for a project shows all the entities we've brought in and all of the data associated with each entity, so we can move between them. And then we can do searches. So like, oh, well, I was thinking something about the glaze. Where did I put that? You can do a search on that to find the object, to find the annotation. And then sort of getting back when you found something, what was the state of things when you made that discovery? And that's a concept of a bookmark. A bookmark saves the state of the system, the objects you had up, the views you had up, so that you can return to that state in that bookmark. And then the important thing is having annotations, being able to attach annotations to record your observations. And it turns out that annotations were more complex than we expected. Of course, we want to be able to annotate any of the kind of imagery we bring in, whether it's 2D images, 3D objects, and so forth. There's different things, like the annotation may apply to the whole object or to just one point, some section. Annotations may be text, or we may have images we want to add into the annotation. And then it was important to them that we had color coding so that you can at a glance understand what the purpose of this annotation was. So we have a whole array of 2D images that can be brought in, and the different kinds of annotations, for the whole image, for a point, for a polygon, that can be attached to an image. For 3D models, technically it becomes a bit trickier how you attach an annotation to a part of the surface or a point on the surface, or it could be a whole volume of the object that's encompassed in a particular view frustum. And then things like the RTI images are like the 2D images, and being able to annotate in the same thing, different sections, points, and so forth. So we have all of these annotations, and we can go back to bookmarks. How do we, when we finish the project, how do you say what's been done? And so we generated this report generator, which is pretty simple. It's putting out for each of the entities, the images and the annotations on the images that were prepared. That's what the report is. And working with the conservators, you can't just put this software on a repository and tell people to go at it. You need to produce videos of how to use it, tutorials, manuals, the whole set of things, and do tutorials for people at conferences or so forth, or no one can use this. A couple examples of using it that we used in projects at Yale is one was for this so-called Pythagorean tablet. It's not actually from Pythagoras, it's from a couple thousand years earlier in Babylonia, and it's some students' homework, which is basically the size of some clay that you would put in your hand, and this homework is computing the length of the diagonal of a square given the length of a side. It's from, Yale has tens of thousands of Babylonian tablets, and this is the most requested one because it's a great math motivational thing about, for kids about, how long people have been doing homework and how long people have been doing the Pythagorean theorem. So in this project, the idea was that the president of the university was going to a meeting and wanted to focus on the importance of cultural heritage, and as a motivation wanted to give out 3D prints of this to all the attendees, with included on the back a QR code that would take them to a page with more information about it. This was just sort of to promote interest and education. So in the project, the entity is this tablet, and then we had RTI images, we had old photographs, and then we wanted to go in and annotate, particularly on the cuneiform, what the cuneiform was saying, how it was expressing the length of that diagonal in terms of the length of the side. And then also the project was deciding, okay, how do we get this QR code onto the 3D object? Where do we stick it? How big should it be? So doing experiments, trying that out, and then sending out for samples to be printed and looking at those results. So these are some samples in the work in progress and one of the sample prints. And then after the whole project, then we could generate this report of the sort of the whole sequence of events, the annotations of the meanings of things. And then after the project is over, for this entity, for this tablet, this is a new piece of data about its history, is its role in this. It was the Davos economic summit that the president of the university went to. So we want to enter in that data about this entity so that in another project that would be available. Another example of a different story is from the Unsleben Jewish Cemetery in Germany. This is was done in conjunction with a long-term project that engages students from Germany and Israel in studying the history and conservation state of this cemetery in Germany. And once again, all sorts of data is available. They've used drones to get this overall 3D model. They've done RTI imaging. And so what the role here was to be able to bring this all in, the map of the different stones, images of them, RTI of the different stones, and being able to look side by side what it looks like in daylight, what it looks like if you can remove the color and just look at how it looks under different lighting, so you can better make out the inscriptions. And just more comparing different objects. And we wanted to use this in a cemetery near us. Grove Street Cemetery is actually, it's famous for being the oldest private cemetery in the US, and it also happens to be conveniently across the street from the CS building. So it's a very useful site, but it is historically important. And it's a great place for interdisciplinary work at Yale, because people in material conservation, in history, literature, there's musicians, it's just lots of different crossroads of lots of different disciplines in studying this place. And in particular, there's been sort of an ongoing off and on project in looking at the conservation state of the various markers in the cemetery. Well, one thing in doing this, we had lots of kinds of data from that cemetery, but once it came to a conclusion to explain what was going on to people who are not at all technical, it's really difficult. It's also difficult if you've done some work in the area and then you leave it for a long time and you come back to it and sort of like, what was I doing? What have we accomplished? And we realized that reading these printed reports just was not making it. I mean, it's just too tedious. And a very concise way of communicating that it's not necessarily fancy or anything, but a relatively quick way to bring people up to speed is to have a video. And there's been research as far as like in heritage domain, people don't necessarily want to read stuff. They don't necessarily want to do a lot of clicking, but just a short video explanation is very engaging and effective. So what we wanted to is an easy way to generate videos about a project. And you could, of course, just take, tab and record yourself doing things, but then you have to be very careful rehearsing it and doing screen captures, or else doing lots of little screen captures and going into a video editing program. We didn't want to get into all of that. We wanted to, how can we generate a video while a person just focuses on their study, on the objects that they're really concerned about? How can we make this as simple as possible? So what the interface for generating a video is, you have this whole project. You select the objects in the project that you want to present and put them in the temporal order you want them presented. And then for each object, the temporal order of the annotations you want to present. And then that's all the user has to do. And then the system will automatically make a series of little animated snippets and pack them together to make a video. It's not going to be like for broadcast TV, but it is does show in animated form the story of a project. But with some very simple choices and organization. So no recording yourself and having to do screenshots, no storyboarding or using video editor. So, and the way we do this is to develop animation scheme for each kind of annotation. So for example, if an annotation's at a 2D point in an image, the animation will highlight that point and put a subtitle there. And obviously if it's a 2D area, that will be highlighted. For a 3D point, we can show an overview of the object and then turn it around and zoom in on that point. is similar for a 3D object. So let me just show you. So for this, this data about the Grove Street Cemetery and about a particular stone marker, we collected this data. This is like a drone shot. We've got RTI imaging. We've got maps and diagrams. This is the entry to the cemetery. Here's the little video that we created. So it shows you the entrance and explains that where this inscription came from. The dead shall be raised. Then it goes to the map, the diagram, and where the marker is on that diagram. And then we go to the drone imagery and highlight in that drone image where the marker is. And then we can go to the site itself on the ground. And then so it's one in this group of markers, and then highlighting the particular marker that we're interested in. And then going through explaining some velocity measurements that were taken through the stone, and some information that relates to the whole stone, and then going in and showing some things on the 3D model. So you get the overall view of the 3D model and some general observations, and then zooming in on particular points on the model. And observing, for example, where there's been some loss of material, and the general discoloration. And then finally, it will go to the RTI imaging, the last data type, where we can change the lighting that allows more clear reading of the inscription. So that it's not a fancy video, but sort of takes you through all the data that was gathered and the observations, all without having to use any video creation packages. And there's a lot more to be done with this. We would like to include videos of data type and annotations on video as well. That would help a lot situate the markers. We'd also like to be able to have an annotation attached to multiple objects so that we can relate them and do a better segue between objects. And then in other domains, as more machine learning is done, and there's automatic annotations, like this is from the manuscript project, where you can do things like you want to look for certain shapes that would indicate certain types of material entered in. We'd like to be able to show automated annotations that were added automatically rather than just the user added. So that's all about the object-oriented view for making sense. And I'll talk somewhat more briefly about making sense of sites and collections. And this has been driven by a long-term interest in Dura Europos and Yale's Dura Europos collection. If you're not familiar with it, it is a site in Syria. It was populated largely from 300 BC to 258 AD. And it's of enormous interest because of the diverse population there. There were a mix of different sorts of people. There was simultaneously Jewish, Christian, and other religions. So you have different kinds of religious sites, all existing harmoniously, at least for some time in this area. In the 1930s, primarily, there were a lot of excavations for people from France, people from Yale. And then, of course, at the end of the excavation, they divided things up. Yeah, so some of the stuff is in France. We have a lot of holdings at Yale, and there's a lot of things in Syria. And what we'd like to do is make sense of all of this stuff, the physical artifacts and photographs of this stuff. and sort of reunite these various collections to make sense of them. And this is a big project. We have all these images of the site at different scales, at different points in the excavation. We'd like to have something that helps you make sense and fuse these together somehow and include some of the drawings and diagrams that were created. We'd like you to be able, again, to annotate. That's a very powerful way for helping people to make sense. We'd like to be able to sort of do sketches, which is in some sense a kind of annotation. And then for the communication to be able to plan presentations that moves through the material and relates the objects to one another. Just Yale's portion of this is quite big. We have lots of individual artifacts, and we have 18,000 images of the artifacts and sites. So we have, besides the individual artifacts, some large views of the overall site and terrain. We have individual buildings. We have these diagrams and isometric views that were prepared during the excavation. And then there's, in museums, portions of this have been reconstruction, and we have lots of modern photographs of that. So what we'd like to do is help people fuse these and get a sense of the site from all this material. For example, these three are all of the same structure at the time of excavation at different points in the excavation. Here's another portion of the site. We'd like to situate these and understand how they relate to one another. We have, this is like a modern reconstruction with bits of the site pasted in, literally physically pasted in. We have other images of close-ups of the material that were made at different times. We have sketches that people made of it. We'd like to combine all of these. So this motivated us for having this sort of photograph sketch organization tool to put these things together to get people to have a better mental model of how this 3D site worked. And one thing people think about, well, let's do a 3D reconstruction of the site. Well, there are some of these physical reconstructions of bit of it in museums. You could build virtual models of this, but a virtual model can't include all the detail that we have in the photos. And of course, even the photos show the site changing in time. One physical model is not going to include all those changes. And we'll never really know what it was like at the time. And doing a traditional kind of virtual reconstruction doesn't show the ambiguity and inconsistency that exist in interpretations. So we were inspired by a couple of things. One was some work from quite a while ago now, from University of Washington and Microsoft, that if you have a lot of images, modern images of very closely related, you can automatically get them put together and then have a tour that shows how they fit together. We'd really like to, this is for a very small subset of the images, the sort of thing you can put together to see how things get assembled. We wanted to have an element like that. And but we don't have enough images for them automatically to come together. And we'd like to add to that the ability to annotate and to sketch. We were also inspired by other work in the graphics group in sketching, in this case, sketching for architectural design. And the idea of thinking of a sketch as something that you make and then you can hang in 3D and move individual strokes off the sketch and gradually make a 3D structure. This is just a little video of that concept, if it will work. It says cannot play media, never mind. So it just has these 3D sketches that you can move together to evolve into well, here, this one works, into a 3D structure. So you see that we sort of hung these sketches around, and then we can go in and move around various strokes to sort of move them towards a 3D structure. This has been commercialized by one of my colleagues for things like architectural design in this product called Mental Canvas. This is an example of this kind of stroke kind of design of Grand Central Station. So you can see the advantage of sketching that lets you see through walls, see the relationship of different things unobstructed as they would be if you just took a photograph. So we set about building a tool that would let us place images and create sketches and annotate them in order to bring things together to make sense. And just as a quick example of this, these are some watercolors of Horace Walpole's house on Strawberry Hill. That we have a Lewis Walpole library at Yale, and they assembled these and located them approximately where they would have been viewing this home. And we use this as an example to show how we would build up a site to understand it. We start out with these canvases that we can enter strokes on, or we can place images on. And we can save bookmarks similar to the bookmarks in Cherub, and we can define new cameras, new viewpoints. So here we start with a base canvas. We place a map onto that base canvas. And then on that map, we can put in a few lines that represent the initial structure, and then bring in images, place them on canvases, and align them with that structure, and then sketch in more detail on the structure. And so that's after we've brought in one image and placed it where it would be viewing the house. And then we can bring in additional views that let us fill in more structures. So this lets us put together this sort of model to, it's not a 3D reconstruction, but it's a model to help a user understand how the paintings relate to one another, how they relate to this simple stroke-based model of the structure. We did use this a little bit with the Dura Europos site to get some models, but at the end of the initial project, we didn't have any Dura Europos experts, so we sort of left it at that. But now we do have somebody who's restarted the Dura Europos project, and we're starting up using this tool again. And this is just an example. Even if you don't sketch a model, these are 5 images of the same gate at the site. And it's hard to tell, but this ledge here is this ledge here, is this ledge here, is this ledge here, and it doesn't show up in this image. So we use the tool to set up where the images are placed relative to one another to show an hypothesis of how the images and the site fit together. So this is a tool that somebody can set up, like, this is how I think the images fit together. Somebody else can say, no, this is that, this should be here. And then we can slowly build up the positions of the various images, and then we can start doing the sketching on them and do some simple models of the structure. In this case, the Palmyrene gate. And this just takes a little bit longer it'll spin out, and then we'll see viewing through the other side of the gate. Initially, it's hard to put together like how this can be the others, how this can be the other side of that, where this seems to be taller, but then you go in and you realize there's these steps, so you can start making this model. So those are the ideas I wanted to present. Acknowledgement that over the years there have been a lot of people who've worked on this, both people from the heritage conservation side and people on the computer science side. We've benefited from the generosity of the Yale collections. and our neighbors on Grove Street. So with that, I'll close. Our software is available, but it is, researchware, right? So you only be patient and really interested. It's not something that I can guarantee you, but just use it. And if you've never seen this kind of stuff before, it'll be easy. But we are interested in feedback and ideas in this domain. So thank you.
Yes, thank you very much, Irma. I saw that you wanted maybe to take some words, to give some words. So please go ahead.
Oh no, I was just wanting to thank Holly for this very important talk, because we're all collecting so many data, especially also in conservation science and technical art history, and you showed some very good examples on how to indeed make sense of it. Very nice interdisciplinary work, and it's all about indeed communication and interconnectivity. And so so thank you again. So I hand over to Zemila, who will moderate the Q&A. Thank you very much again.
Yes, thank you very much, Holly, for a beautiful presentation. I heard that once you defined yourself as a tool maker, because machines do not see and do not learn, people do. And I think that you gave many great examples of this. And as Irma pointed out, your work really shows how your working team is interdisciplinary, and we all understood through even the past sessions, how this is a necessity in this field. And yes, I would like to read some of the questions that the audience asked. So I would like to go to the first person, Morgana Rodriguez. She asked if the annotations are ordered chronologically or in any other way at the report. And yes, she congratulates you with the CARE OB software.
Yeah, I don't remember right now for an individual element what the ordering of the annotations are, whether it's the order that you entered them or if there can be some other order. So, sorry.
All right. Yes. And then Francine Bosma, she's a close collaborator of mine at CWI. So she asks, maybe Francine, if I unmute yourself, you can directly ask the question.
Yes, sure. Thank you, Zemila. Thank you, Holly, for this nice presentation. I think you showed very interesting and nice case studies, and I was thinking that this software is interesting for many projects, as Irma as well said, that many projects have lots of data and don't really know how to combine them in a meaningful way. So I was wondering whether beyond Yale and your collaborators, it has been implemented by other museums, other heritage sites.
I don't really have other examples, like Eleni, who was one of the postdocs who worked with us, has used it in her subsequent life on other projects. And I know other people have downloaded it, but I don't have reports of other people doing projects. And one problem is keeping software up to date. I mean, we do have all the source there and stuff, but people have the energy like, oh gosh, I have a newer version of Windows than the original compilation. The people who have the energy to go through and recompile. So this is a problem that we're confronting. And I think part of the answer to that is to change the tool set used, at least for front end. It's not so much to have it on the web, to have it on the internet, but to use the kind of web tools like JavaScript, HTML, and so forth, because I think those are easier to keep up to date. We had been using Qt. I mean, this is all technical, but we had been using Qt and so forth for the interface on the compiled versions that you have to download on your machine. And keeping those up to date and fresh, there's just a smaller people who know how to do that. And so it's, I had resisted making sort of web tools because I didn't want people to have to be hooked up to the internet to use something.
Yes.
But there's a difference between a web tool and being hooked up and using the software set of JavaScript, HTML, SVG, that sort of thing. So I think, you know, in the most recent version of Cherish that we're working, we have a student building up a JavaScript Vue.js version of the system. And that little example I had, the last example I had from Dura is created using that. Although, of course, every time you recreate something, that student leaves out some things that were really important in the last version, and you have to pester them before they leave. So yeah, I am a victim of this sort of software going stale and a turnover in student population.
Yeah,
so
like you would certainly have someone maintaining it on the long term, but that's difficult, of course.
Yeah. Hopefully, if you can get like a critical based community, there's people that can do that. But you know, you need right now you need a group where there's somebody who specializes in software, and I realize in this domain people can't afford that. So we're still a problem we're working on.
Okay, thank you.
Thank you very much, Holly. I had a similar question, but I think you already replied. I don't know if you would like to add something. I had a question on Kerobi. What is the long-term vision of the future development? You already replied pretty extensively to Francine. So I would like to go to another question I have, and this is somehow related. No, not really related to multi-data. I mean, this is a topic you mentioned, but it's not strictly related to that. So it was basically more a reference to the fact that when I was researching myself publications on artifacts being collected at archaeological sites, I would read that the most desired, the easiest approach for archaeologists would be to bring 2D cameras because they're indeed user-friendly, they're easy to transport, they're not complex as more sophisticated imaging systems. And this, of course, was super useful for acquiring images of small shards, clay objects. And my question would be if you think that 3D scanning will be more and more used in upcoming years, or if this will be a slow transition.
Well, the thing is that area has transitioned tremendously from having to bring the scanners, the active scanners, LiDAR and stuff, to the between the improvements in cameras, the higher resolution, and then the improvement in algorithms. Basically, you can scan a site by getting a tremendous number of high quality color images, which is why the drones have taken off literally, right? If you take a drone and take it back and forth over a site, you get a huge number of images from which you can create the 3D model. And so this seems to be an extraordinary innovation, that people in archaeology have adapted for sites, right? Because sites are continually being destroyed as you excavate them, and now you can just fly the drone back and forth over it, and each day document the shape of the site. So I'm not, and now increasingly just in phones, there or iPads. They are incorporating LiDAR in like iPhones, so that you essentially have a scanner in your phone. And so we're looking more like what you can do with that data, how it compares to the image data. So I think people will be making a huge number of scans of 3D shape. I think one thing and besides there being the huge change in that, making it very accessible, where people, hobbyists,
without having to bring the photogrammetric system.
So there's a couple of things. Is one thing is so you've got that's just the shell of an object. There's a lot more to an object than just its outer surface. So how do we capture more about that? So that's one concern. And the other concern is, where's all this stuff going? A lot of people are uploading things like to Sketchfab. And and what's the future of that? I mean, is that going to be, I mean, it's a company, right? So, and so this is another concern, and one that we're looking at in the newest iteration of Dura Europis is where do we put and share data? And in that project, we're taking the approach of using Wikidata to have data that can be accessed in different facets, and trying to get it. I believe we'll get all of these 18,000 images. Right now they're available for free via ArtStore, but we'd like to put them in Wikimedia because it'd be very easy for people to crawl.
Yeah, indeed.
Query a bunch of data and bring in the images and really use them. And then we hope that this additional information that we're putting together, like Anne Chen, who's the lead on that project, is entering like all the fine coordinates in latitude, longitude. So there's a whole bunch of things involved here, and where do we put the data and how do we make it most accessible is really critical. But initially I was skeptical of how the photogrammetry, it was going to go. But if you use appropriate scales, references in the images, because of the very high quality images, you really can get very good models easily, and the quality of a camera and an iPhone is really quite impressive.
Yeah, it is.
Compared to, I mean, like when we were making the model of the Florentine Pieta 20 years ago, I mean that camera was absolutely shabby compared to what you have in your iPhone now. So
yeah, indeed. But still quite fascinating to see. I mean, to go back to your research at IBM years, and learn what you were able to retrieve back then. It's fascinating, considering that it was indeed done 20 years ago. So I would have other questions related to photogrammetry and how you scan that, but I saw that you skipped that, so I will move on to other questions. So. Yes, there are plenty of compliments for your presentation, and there is also Stefan Simon, or Simon. I'm really sorry if I pronounced this incorrectly.
Oh, Stefan! Hi, okay. I didn't know you're here.
If he's here, maybe he could unmute himself.
Yeah, I would love to see you. Hello.
Hi, Holly.
Hi.
Compliments for a wonderful lecture. Thank you.
I hope you were represented appropriately. Stefan was in charge of a lot of the IPCH when we were doing this work. So, and it had to do with Grove Street and Unsleben. So, I'm so glad you're here.
Yes, wonderful. I saw that on Twitter, and I told all my friends to really come and see you, and because it's always worth to follow up what you're doing. And I'm sure actually that what also the links to the computer science department, computer graphics is very, very helpful and will profit from further implementation. So don't wonder if we contact you with further questions here from the National Museum in Berlin. I will write to you, but thank you very much.
Great. Yeah, I wish you were here because Anne Chen is a real go-getter on this Dura Europis stuff. So I feel like things are reviving. So good to see you.
Great to see you. Yeah.
Good. And we had a question from Nicola Liu asking, how do you manage the large volume of data needed to be rendered in the software interface? Yeah,
that is a huge problem. And And things do slow down tremendously once you keep bringing things in. And the only remedy thus far is innovations people have made for individual data types. For example, high resolution images, dividing them into little squares and downsizing them, only retrieving the resolution that you currently need, or only retrieving the bits the pieces you currently need, and a similar kind of approach for the 3D surfaces. And frankly, our most recent share doesn't have the most modern versions of that that would really help in dealing with the things getting bogged down because you run out of memory. Because no, it doesn't. I mean, when we did the project in Italy, IBM was so incensed with us because we brought back our computer for backup, and we wanted them to back up 8 gigabytes overnight. Like they were like, you can't just throw 8 gigabytes out. No, I've laundered 8 gigabytes accidentally with stuff I left in my pockets. So no matter how much memory and stuff we get, we will always overwhelm it. So it's kind of an arms race. We'll continually have to think of better ways. But one thing is, the screen's only so large, so figure out how much you need to fill the screen and only retrieve that.
All right. Then we have a question from Hub Baya. Again, I'm really sorry if I pronounce this incorrectly. And he or she asks you, do you suggest these programs instead of or supplemental to GIMP, Inkscape, and the like?
Well, I mean, things like GIMP and Inkscape are incredibly useful and well-supported open source projects. The thing with ours is we don't have those communities that those programs have. So you're kind of on your own. If the compiled version doesn't work, you've got to go and find all the pieces and recompile. So it's sort of your individual stamina, but yeah, because the hope is eventually that we would have a tool that would get a big enough community that would have the same kind of support that something like GIMP has. But yeah, definitely don't stop using those. Those are incredibly useful.
Something that I would like to mention, as I received a message that Holly's presentation is recorded, will be available later, and the other presentations are, so the presentations before are available already. I asked Francine if she could please share the links in the chat. Then we can move forward. Doug Emery, thank you for this terrific presentation. Does Kerobi offer data and metadata export? I'm wondering about preservation and sustainability of the data after projects are complete.
Yeah, that's a good question. Well, since we had people enter metadata and stuff, but we didn't really have a good place to return to. So I think this is something now that looking at Wikidata and so forth, that if we were to do a next generation, somehow doing an export to Wikidata entries would be the way to go to save things in. And I talk about that because the whole wiki phenomena is the sort of thing where there's a huge user base now. So it's taken on a life of its own. I mean, you may not like Wikipedia because, who knows how reliable things are in there. But the thing about Wikidata is it's individual facts and you can check the documentation for that fact. So that makes it kind of a different animal from say a Wikipedia article, which is somebody wrote and it's got their opinion and so forth in it. But Wikidata, you can it's traceable. You can see whether you're going to trust that fact. And so that would be a good place to export things to make it available and for long-term preservation. That's, like I say, in our current project, something we really want to, an idea we want to push.
Thank you. I don't see further questions. Okay, Doug Emery is also adding at UPenn libraries, we're looking at Wikidata and Wikibase for our metadata handling.
Oh, good to know. The more context we have to sort of build up the momentum.
Maybe Doug Emery could unmute himself if he would like to discuss this further.
Yeah.
So I work in the, thank you for the talk. I work in the Special Collections Center at Penn Libraries on cultural heritage projects. And one of our primary projects is the Schoenberg database of manuscripts, which is actually a collection of, it's a provenance database. It actually doesn't contain manuscript records, but actually mentions of records and catalogs. And we're increasingly looking at, for us, the Wikibase and Wikidata are important because we're becoming unsatisfied with the state of current authority records. So we, in order to get in the Library of Congress, authority records, you have to be an author, you have to have certain status, but there are all kinds of names that we would like to be able to record in some fashion. And we're becoming less and less interested in authorities, but more interested in URLs that we can rely on, that we could change out at a later time if they become replaced with something better. So for the Schoenberg database, we've been using VIAF, but we're thinking about moving away from that to using Wikidata and using that as a hub for connecting to other authority links. But we're also looking at it for other projects. We're planning a project now to create a union catalog of the manuscripts in the United States. This is a planning project to apply for grant funding, but we're looking at Wikibase and Wikidata as a way to store that information.
Yeah, so we sort of, because there's sort of the top-down authority kind of base design everything and then the wiki is sort of bottom up and getting stuff out there. But it is something you can trace and verify, right? And so that's the other thing is to look at building tools that can sort of do this so-called round tripping that that you can go back to the source and the source can go back and update. But it seems like the fastest, so you have the institutional base of information, and then above that, this cloud of Wikidata that accesses it. So the institutions don't have to agree with each other on what they're going to do and stuff. It just seems to be a fast way to build up this totally interlinked, and it's really important for some place like Dura Europa, because there may be people that are studying Judaism, so they've got other information, and then they want something about that synagogue, or they're studying Roman culture, so they want another segment. So it's not just you want to go to the Yale collection and look at something. It's a little piece of a larger thing you're looking at, and we don't have everything you need. So you need this interrelated base of information. So that's really exciting that you are looking at that as well.
It's really exciting having just having a URL, having this identifier that you can then that different people can hang off of it, whatever, as you're saying, they can hang off of it what they like. And it doesn't have that kind of, as you're saying, this sort of heaviness of the authority record.
Well, the other thing we're interested in is multilingual, so that in the record, there's different languages, right? So that you, by connections, what we want to do is make everything available in Arabic, for example. Well, we can't translate everything, but if you have a record and you have the different terms in different languages, sort of by tracing through, you can slowly make things available in a wide variety of languages without having to have translators translate pages and so forth like that. That's another big aspect of sort of worldwide connectivity.
All right. Thank you very much.
Ask one more
Sure,
question, Jamila, if there is none
Absolutely.
in the chat? Okay. Yeah, I was wondering, Holly, you said at the beginning that it's important to share research results with the broader public as well, so science communication or outreach. And I was wondering if you, it was just a small remark, but I was wondering if you could elaborate on that a little bit. I find that very interesting, how to communicate with a wider public, and if you have had any experiences using this software as well to do that.
Yeah, well, so of course the main domain I work in is education, right? So that it's a good way to get students, you have school tours and stuff to get kids information. Because I'm interested in getting them interested in math and science, but you show them this other thing that you can use it for, and other things that you can do with it. But I think, I think it's because it's such an under-resourced area, again, that it's really important to make it clear to people why things are important. And when we do tours and stuff too, so you have these 1,000 manuscripts. Why should anybody care about them? And sort of introducing them to, like, well, this is about the evolution of the book. Like, how did we come up with the idea of a book, and what's in a book? And you can start showing them examples of that. It's important to communicate, why we're doing this. I think, it was fascinating in the first lecture that, the envelope was an idea that evolved.
Yes.
You're like, wait, we could have a whole nother piece of paper that we wrap around. I mean, who knew that was like an idea? So, I think that's an example of a fascinating project that really can get people excited, and, why we study this stuff and why the technology is useful. And
yeah, thank you. It's very interesting to hear your views on this.
Like, there was a world once without envelopes. Who can think of it?
Indeed. All right. I think there are no further questions from the audience. So I would leave the word to Irma, I guess. And I would like to thank you, Holly, very much again for this beautiful presentation. We learned a lot. Yeah, I'm really happy that you accepted our invitation this year as well. Thank you.
Oh, it's wonderful meeting people here. Thank you.
Thank you indeed, Holly, for your presentation and all the attendance for a good discussion, good questions. I'm just wanting to announce the last talk in our series, which will be on the 22nd of June, same time, 4 o'clock. It's called Point Cloud to Sound Cloud, Digital Innovation and Historic Sound and Linlithgow Palace by Sophia Mireshravi from Historic Environment Scotland and James Cook from the Edinburgh College of Art. I think it's a very interesting and a very exciting project where they use 3D scanning of the chapel in Linlithgow Palace, and they push the boundaries of virtual reconstructions by recreating a 16th century concert with the historic instruments, acoustic and sound of 1512. This is really quite unique research, very interesting. So I hope we can welcome you all back for that fourth and last, unfortunately, talk in our series. So I wish you a pleasant evening and hope we see each other again. And thanks again, Holly.
Bye.
Irma, can I just remind you that we will write a blog post on these?
Yes. There will be another blog post on looking through art blog. .wordpress.com. There you will also find links to the recording. This session will be recorded, so you can see it again, and you will find blogs on the previous two sessions, including links again to the recordings. Yes,
thank you very much again. And have a nice morning or afternoon, evening. Thank you very much. See you next time.